Storage has always been something of an afterthought in a lot of architectures, as you know. It's been the next to death and taxes, that other certainty that was unfortunate, but we all knew we needed, right? What I'm very concerned about, though, from a practical economic standpoint, is that a lot of the software-defined storage architectures, the hyper-converged infrastructures, they're also going to multi-node storage behind the server, and then replication patterns that are very hard to fathom between servers, because now you got multiple nodes behind each server of storage. We seem to have made things more complicated, not less. And I read an article, I think it was in Information Week about a year ago, the original virtual SAN from VMware, to set it up with certified nodal hardware for the minimum 3 nodes is going to cost somewhere in the order of $90,000. And I'm like, wow, how many small companies that have one server that they're trying to equip with storage have $90,000 sitting around in order to build infrastructure behind this thing, yet at the same time they're villainizing the high cost of legacy gear. Yeah. My understanding is that one thing that really hasn't changed about DataCore is that you're able to support configuration of storage I already have deployed, as well as the newfangled stuff I may be throwing behind. And you're doing the Lord's work as far as I'm concerned in that regard. You're also keeping my prices down. Now, you simplify that infrastructure, though, and always have, by not only virtualizing the capacity, but also virtualizing the plumbing.
Yes.
So I don't have to be an expert on worldwide naming and so forth in order to set up the interconnects and balance the interconnects should a switch port die or something, right?
Correct. We do the self-discovery of what's out there. We'll load balance across that. If there's a fail, it basically reverts to a different path. I mean, these are fundamentals to me in a real world environment,
Sort
which
of
is
like somebody
conveniently ignored by many people.
Sort of like somebody knew what storage was before they started designing the product. What do you think?
Yeah.
And I want to emphasize active-active.
Yeah.
A lot of people talk about failover clustering, a lot of people talk, but usually that's active-passive, and you have to have some sort of mirroring process going on, and then you pray to God that when you fail over, the data you need is over there. Yours is active-active, the data's there all the time, right?
Correct. Not only active-active, but like I said, it's a natural stretch cluster. I mean, high availability to me is very simple. You have to have 2, and they can't be in the same device. Mm-hmm. So every time I watch these folks with whatever the latest newfangled thing, whether it's a big pure storage box or a big old EMC or whatever, I even see the sales guys hit the side of it and go, see this big thing? It's solid.
Right.
And then they point to the dual power supplies and the whole thing, and they go, God, this thing will never fail. Now, guess what? I've been in too many shops where the water drips on the top, and that whole thing is a single point of failure.
That's for sure.
So what happens is real simple. DataCore, 2 instances. You can run them on VMs, you can run them on hardware platforms, and you separate them. And by the way, just even 10 feet separate in a different rack is an order of magnitude better for high availability. But let me go back to something you said that was interesting on that hyper-converged and all of that. The other big thing I've seen is originally the hardware guys came out with the storage controllers. Each storage controller was a separate data island to manage. Then the applications get more complicated, and VMware comes along and all of the virtualization hypervisors, and they make the ability to run these core applications pretty difficult, and that's really been the struggle. How do I run my Oracle? How do I run my SAP? These sort of transaction-oriented stuff, how do I really get them running on a virtual platform? And first wave is, we're going to throw Flash at it. And Flash is a good thing. 10% of your applications need it. Now, we're going, let's go pure Flash. Well, you can if you have a lot of money and you like to throw it around, but is that the optimal way? That's why we do things like auto tiering. Let the system figure out your optimal use and your optimal cost, because it is an economic game after all. Mm-hmm. Then comes hyper-converged, and hyper-converged says, we're going to make it faster, they're going to make it simpler, and they're going to make it less complicated and easy to deploy. Then I look at the realities. So, for us, 2 nodes basically is a high availability solution. I look at the likes of EvoRail, I look at things like Nutanix. You're talking 3 or 4 nodes just to do high availability. Well, just cost alone, that's a third more at least. Complexity? Okay. They basically defaulted so it only does, for instance, iSCSI or some other series of things. Yes, that's good if that's all you want. And by the way, with software, we can default it down to that level. But what actually happens when you really want to run a database, which, by the way, most of them are running things like Fiber Channel, which I know supposedly doesn't exist, yet I find in most shops that are running databases.
That's for sure.
So there's this disconnect. And then what happens with these hyperconverged? They're really yet another data island to manage. Look at DataCore. I've got a common management platform, works across hyperconverged, works around over traditional SANs, works with even cloud storage, allows you to aggregate across all of that stuff, manage across it. You're not left out there in the open. And technologies like these hyperconverged, they're an aggregation of different device types, each independently on a different technology curve of evolution. So a year from now, the CPU got faster, the flash stuff changed, the hypervisor, who knows what hypervisor you're going to use, etc. What happens with all of this?
Right.
So there's this big
a lot of moving
trade-off.
parts. That's right.